In this section, we're going to look at how do we divide complex numbers. And really dividing complex numbers isn't always necessarily dividing, although eventually we could, but really what it is basically getting the I out of the denominator. Okay, so whenever we talk about dividing, it's really removing I from our denominator. And so how do we do that? Well, if we have just a single term, okay, so if we have like AI, all right, so if we had like 7 over I or something like negative 22 over I, then what we're going to do is just multiply the denominator and numerator by I. Because remember, we could write 1 as I over I, and that's going to help us to be able to get rid of it. If the denominator is of the form a plus bi, we're going to multiply by a minus bi divided by a minus bi. Okay, so we would have a minus bi over a minus bi. And then if it's a minus bi in the denominator, then what we're going to do is we're going to multiply by a plus bi over a plus bi. So these are the three possible quote unquote ones I can divide by because 1 equals 1 equals 1 equals, okay? That's called the conjugate, okay? So the conjugate of a plus bi is going to be, for our conjugate, is going to be a minus bi, okay? So just keep that in mind if I say the word conjugate throughout, that's what I'm really doing is I'm multiplying by just changing the sign in the middle, okay? And we'll see what good that does. You might think, okay, well, what's that going to do? It's actually going to help us pretty well to be able to divide. So 3 examples. The first one's going to be the easiest. So we have 6 divided by I. So what I'm going to do is I'm going to take 6 divided by I, and I'm going to multiply that by I over I. And you might be thinking, okay, well, what's that going to do? Well, the numerator, if we multiply straight across, is going to become 6i. The denominator is I squared. We remember that I squared is the same thing as negative 1. So we get 6i divided by negative 1 or negative 6i. All right, so, and remember, the whole goal is to remove the I from the denominator, which is what we just did. Okay, so that one's pretty easy. Another example is 6 divided by 4 minus I. All right, so this is where we have to multiply by the conjugate. And our conjugate for this one is going to be when we multiply the top and the bottom by 4 plus I divided by 4 plus I. Okay, so that's what we're multiplying by. Right? Now the numerator, if we multiply this out, then what this time turns out to be is 6 quantity 4 plus I, and the denominator is going to be 4 minus I times 4 plus I. And now all we're going to do is just turn this into a FOIL problem and distribute. So in the numerator, we get 24 plus 6i by distributing. And then in the denominator, we're just going to say that 4 times 4 is going to be 16. And then 4 times I is going to be 4i. Negative I times 4 is a negative 4i. And then finally, negative I times negative I is going to become a negative I squared. And it looks like that we just made this thing a lot more difficult, but in fact, it actually helps us because check this out. These are opposites, so they cancel out, and we have a negative I squared. Well, negative I squared is the opposite of negative 1, which is a positive 1. And so this is going to turn into 24 minus 6i, not 16i, excuse me, divided by 16 plus 1. And of course, we know that another way to write this would be 24 plus 6i divided by 17. And I believe that we want to write everything of the form a plus bi. All right, and so to do that, we're just going to divide this out. So this would be 24 over 17 plus 6i over 17, right? All right, so in our last example, we're going to do the exact same thing, okay, except this time it's a little bit nastier. So a suggestion might be to give this one a try on your own and then watch the video to see if you got the right answer or not. First thing we're going to do, okay, is we're going to multiply both of the terms in the numerator denominator by the conjugate, which is 1 minus I. All right, so we're going to multiply the top and the bottom since it's 1 plus I. We look at the denominator. We don't care about the numerator. and it's going to be 1 minus I divided by 1 minus I. Right? And of course, if we multiply that across, we're going to get two, I'm going to say quote unquote binomial terms. So 3 plus 5I, 1 minus I divided by I plus 1 or 1 plus I, same thing, divided by 1 minus I. All right, now we're going to FOIL in both the numerator and the denominator. So we get 3 minus 3I plus 5I, and then plus or minus 5I squared. Right? Now what we're going to do is we're going to FOIL the denominator, and we're going to see that some good stuff happens. So we have 1 times 1, which is 1. 1 times negative I is negative I times 1 is a positive I. And then finally, I times a negative I is a negative I squared. All right. Now, of course, we remember that I squared is negative 1. And in this example, we have two negative 1s. Right? So this is going to turn into 3 plus 2I, net minus 3 plus 5I. And that just turns into plus 5. All right. So remember, when you multiply by I squared, it just changes the sign. In the denominator, negative and positive I are opposites, so they cancel. And we have a negative I squared, which is going to be the opposite of negative 1. And so we just get 1 plus 1, which is 2. And so one way to simplify this would be 8 plus 2I divided by 2. Of course, we want to write it in the form a plus bi, so this would be 8 over 2 plus 2I over 2. And then finally, the most simplistic that we can make this is going to be 4 plus 1I, or 4 plus I, by dividing those out. So that's how we divide complex numbers. We just either multiply by I over I, if it ends up being like a single I in the denominator, or we multiply by the conjugate, which is just changing the sign in the middle of the denominator. Okay, we don't care what the numerator is. The numerator can be whatever we want, whatever it wants to be, but we just change the sign to get to that conjugate. Okay. All right, so in the next videos, we're going to take a look at some more advanced examples of being able to work with these operations on complex numbers. And then the last video in this section, we're going to take a look at how do we solve quadratics that have complex roots to them.